Okay, to solve question 7, it does say to solve by graphing, and then it says to check your answers, and we can do this two ways. We can take the equation as it is originally, and we can graph this cubic. We can graph the right side, which is a quadratic, and we can find where they intersect, where 4x cubed is equal to 4x squared plus 3x. Remember, a solution is any value of x that makes the left side equal to the right side. So those points that they share in common will be the values of x that make them equal. So we can do it that way, which we will, or we can set it all equal to 0 and then find all of the x-intercepts, or what values of x will make y 0. If you take a look here, I already have it in the calculator both ways. I have y1 is equal to the cubic, y2 is equal to the quadratic 4x squared plus 3x, and then I have it set equal to 0 here in y3. If you notice, this is not bold, so that means it's not going to be graphed. So if we take a look at this graph, it's only going to graph y1 and y2. And it is a little bit tough to see. Let's see. Maybe if we change our window, x min -2, let's go to an x max of 4, let's count by 1, let's go to a y min of -1 all the way up to 10. And let's see if we get a better look at that graph. There's one intersection, 2. It looks like the third one is up there somewhere, so we'll need to go back to our window and take this y max, and let's just take it to, well, let's try 15. See if we can see it now. So here it comes down, 1, 2, 3. Looks like our third intersection. I don't know if we'll be able to pick a left bound there. So what I'll do, window, let's go to that y max. Let's go all the way up to 20. Let's take a look at it one more time. Okay, there's the cubic. Here comes the quadratic, 1, 2, 3. And then we just want to take second calc, and we want to find the intersections. Okay, the intersection of, let's see, first curve. Let's take it all the way up past that intersection there. So enter. We're on y2. Enter. Guess, and it looks like the intersection is at 1.5, 13.5. So in this case, one of our values of x is 1.5, so that's one of our solutions. Second calc. Let's go to intersection again. Let's go a little bit closer to that second intersection. Maybe I should have changed this window. We'll go a little bit closer here. We are on y1. Take a look in the top left corner. So y1, y2. This should give us what we need. We're on our second curve, y2. Enter. There we are at 0, 0. So that's another one. And then second calc and intersection. Let's get over here by this other intersection. So there we are on y1, enter, second curve, y2, enter, and we'll guess. And there it is at a -1/2. So it looks like our zeros are -1/2, 0, and +1.5, and that's by graphing the left side, which was the cubic, and the right side, the quadratic, separately, and finding their points of intersection. Left side equal to the right side. The other way we can do this is we can turn this one off, we can turn this one off, and now we can set it equal to 0 and turn this one on. And what we're looking for is, now we're looking for what values of x make the function 0, so we're looking for the zeros. We go to second calc, the first 0, too far, left bound, enter, right bound, let's get above that 0, I think we have. Guess, that should be a -1/2, it is. Second calc, 0, left bound, I think we need to get over there. Oh, we are at 0, 0. So let's go there, see if we can do it left bound. We can actually zoom in, probably make this a little bit easier. Right bound, guess, it should be 0, 0, it is. And second calc, 0, left bound, gotta get across this relative min. Left bound, we're still below the x-axis. Right bound, guess, and this should be our 1.5. And it is. So those are two ways to solve this equation, or this question, this function equation, by graphing.